Good morning, students. Can you hear me? Can you hear me? Hello, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. Okay. Now, I'm Dr. Gainla Parnavidhana. I'm using our department head's account to conduct this class because I have a limited privilege to access your course. I am going to be the course coordinator, your academic coordinator for this CVX 5450, which is a new course code. But this course has been existing for about as CVX 5530. Now, before starting, since we have to conduct a survey camp in this course, I would like to get some contacts of yours from each district so that I can communicate to all of you separately. So, first of all, can somebody from Colombo speaks to me? Because I want to take down some contacts of yours because we need to start communicating about the survey camp from the beginning onwards. Anybody from Colombo?
Yes, sir.
What's your name, please?
TJAS Yapa.
Tanuja Apa. Am I right?
Yes, sir.
Can you just tell the name again, please?
TJAS
J.
Yapa.
Yapa.
TJAS Yapa.
Yapa. Can you just send your email through chat. There is this chat section. Can you type your email? Yapa, can you send your email, please?
Okay, sir.
Then somebody from Matara. Are there any students from Matara?
Sir, here,
You are Kalani, right?
yeah,
Kalani, you can also send your email through chat.
okay, sir.
At the end or in the middle, I'll give you an email to all of you. You can drop an email to me on that email, which will be dedicated for your surveying course and also for this survey camp as well. Because
Sir, I am, excuse me.
yeah, yes.
Sir, I am also from Mathura.
Okay, okay. If I
Excuse
can
me.
have one person to communicate, so because I'm thinking of arranging a coordinator for each district, like, so
Okay, sir.
you can have a group in your own district and you can communicate among yourself, ne? So that is my plan, because
Okay,
organizing
sir.
survey camp takes a lot of work. So I want to start it from now onwards. Okay. Okay. Then anybody now? Anybody from Gaul, Kalutara, that area?
So I am Kalutara, sir.
You are
UGRPC Kumar.
UGRPC Kumar.
Yes.
Kumar. You can also send your email to
Okay,
me
sir.
through chat, and
Okay.
later I will give you an email so that you can drop an email to that.
Okay.
Okay. Anybody from Gaul? Anybody from Gaul?
Yes, sir.
You're Fernando.
Yes.
WM Fernando. Somebody from East, Trinco, Baticlo area. Are there anyone from Trinco and Baticlo? Nobody? Okay. Anybody from Jaffna?
Yes, sir. I'm from Jaffna.
What's your good name, please?
T. Ave Maria.
Ari Maria.
Ave Maria.
Ave Maria.
Yeah.
Can you also send your email to me? Sorry.
Yes, sir. Yes.
You're from Jaffna. Now,
Yes, sir.
Jaffna representative will have a special work because you will have to identify the vegetarians. Because there are a lot of vegetarians who are coming from Jaffna, and I need a full list of vegetarians who are going to attend to the survey camp. Later we will communicate, Maria. Okay. Anybody from Anuradhapura, Polonnaruwa area? Anuradhapura, Polonnaruwa? Nobody? Then from Kurunagala, Putlam, Nikambo, from that area, are there anyone? Okay, are there anybody from Central Province, Kandy, Matale, Nuwara? Are there anybody? No?
Sir, I am in Matale.
What's your name?
Indika Amarasuri.
Then anybody from Ratnapura, Kegol?
Sir, I am from Kurunagala.
You are from Kurunagala.
Yes.
What's your name?
Madhusha Herat.
Madhusha Herat. Okay. Are there anybody from Nigambo, Chilao? That nobody? Okay. Somebody from Kegol, Ratnapura, that area? Sabaragaon province?
Yeah, I am from Kegol.
What's your name?
Anuradha Suravira.
Okay. Anybody from Badulla, Monoragala?
I am from Badul.
What's your name, please?
Asia Nigeria.
Okay, somebody from Hambantota.
Yes, sir. I am from Hambantota.
What's your name? Shamila.
MRI? Yeah, sir. MRI Shamila.
Shamila.
Also from Hambantota.
Okay. I only need one person's name as a communicator. Later we will develop a group.
Okay, sir.
Right. Now, what are the songs that I missed? Anybody from Kilinochi, Vaunia? No? Okay, now in this course, you have final exam, you have CAT, continuous assessments, and you have all CAT, then you have survey camp, quite serious for you. Then in that survey camp, after survey camp or before survey camp, I will conduct an instrumentation viva, in which I will check your skills to handle instruments, especially theodolites. Because I have realized during last year, there are students who cannot even handle an instrument properly, who are trying to pass the subject, which is bad for you and it is bad for us as well. So it is quite important for you to have instrumentation skills, and it is so I'll test you on that. Then regarding this course, the conduct of this course, I want to clearly say one thing, that are you all familiar about ODL? I believe that you are familiar with this ODL system, right? This is called open and distance learning, right? So when we try to do open and distance learning, the matter is that we don't do conventional teaching. We have given you a course material. I believe all of you have collected course materials. Are there anyone who has not collected course materials yet?
No, sir, still not, sir.
Why did you?
We didn't get.
Why?
Cannot enter, sir, L-learning.
Sorry.
Not in L-learning, sir. Where we can collect that?
Yeah, you have to collect it from the regional centers, or you have to buy it from Colombo Center.
Okay, sir.
Now, without these books, it is extremely difficult to follow this course, right? Because in conventional universities, what we do is to conduct the full course as a taught course, right? We do conduct lectures for all the lessons which are there to be taught or which are there to be introduced. But in this case, we find it difficult to deliver all the lectures in 8 or 10 hours, which requires 45 hours of lectures. So therefore, this course material, studying the course material is extremely important. I will iterate, it is extremely important, right? So since we are doing this course this time online, I'll try to do extra classes for you. But still the course material is the major one. Okay. Right. Then about the exam, final exam, I'll test your skills to analyze. Now this time around, last year I gave a paper to students, and they complain me that it is difficult and so on and so forth. But the thing is, there is a certain standard an engineer should attain. We expect that you to attain by yourself by studying. Please remember and start studying from the beginning onwards. Otherwise, do not wait until last moment to study, because there is a lot to study in this course. That's all I want to brief you about. Now, I'll move into first lesson. Can you see this? Hello, can you see this?
Yes, sir.
Yes, sir.
Okay, good. Now, Now, if you go to your course material, the first lesson is about curve ranging. Here I am trying to explain few things as much as possible, but you really have to read the course material and work it out yourself to understand all the fundamentals of it. Now, curve ranging is a subject which normally occurs in highway and irrigation, mostly in highways, and sometimes rarely it is used in construction as well. Now, there are different types of curves available. Basically, there are three categories of curves: simple curves, compound curves, and reverse curves. These are clearly iterated in your book, and we will go one by one. Now, regarding the simple curves are, they are circular curves which are connecting two directions or two tangents together. Now these tangents here, now if you see this tangent and this tangent, they are connected using a circular curve. Now there are properties of tangents, and all those properties are inherited by these curves. Now, for example, if you want to calculate the length of this AI, where I is the intersectional point, normally it comes up as R tan delta by 2. Now, delta, this angle here is the angle induced in the center of the curve by this arc. So if you want to calculate the length of this AB, if you measure this angle in degrees, with your maths knowledge, you know that it is R theta, right? Now this represents the angle in the induced in the center. So if you multiply this by this angle in radian, you will get the arc length. So now in these curves, one of the major challenges is to establish this starting point A. Now normally when a road comes like this, if you want to decide the starting point, you know the two directions that you want to divert the vehicles. But in order to find the starting point, there are several methods available. Now, if you can get the intersection of these two tangents, and if you can find this point I, it is not that difficult to establish this point A or point B, because this length can be found, and if you get the chainage of I, you only have to deduct this length AI, like here, chainage of A equals chainage I minus tangent length AI. So So this establishing initial point is a key element in your study or in your establishment. Sometimes people make mistakes of not selecting this point properly. Now, I believe you can understand the mathematics behind this. So I'll skip into the next slide. Now, here we are describing about compound curves. Now, in compound curves, there are more than one or two curves combined together in order to create a transitional curve or a direction changing curve. Now, for example, if you look at this picture, you need to change direction from this direction to this direction, which is going away from C and which is coming towards A. Now, in order to fix these two directions, here there is a compound curve proposed. Now, in this thing, you can see that there is a radius R1 and there is another radius called R2. Now, these are arcs of two different circles combined together at point B, as you can see here. Sorry, there is a problem of running animations in this, so I am trying to figure it out how I can fix it. Now, in this slide, you can see now this point is called the point of compound curvature. Now this point is the common point, and there is a common tangent which can be drawn to this point for both the curves. Now, there is a need to understand the difference between a compound curve and not a compound curve, non-compound curve. Now here, if you look at this picture here, you can see that there is no common tangent for this particular point. So no point of compound curvature is there. So such a curve is not considered as a compound curve. Now the next slide discuss about the geometry of these compound curves. Now you can see that this arc here AB can be written as an equation of this r and theta, and this arc BC also can be written as an equation of R2. So finally, you need to find the chainage of point C with respect to point A. In order to find the chainage of point C with respect to point A, first you need to find the chainage of point A. In order to find the chainage of A, first you need to find this particular point of intersection. Now from this point of intersection, if you deduct this IA, you will get the chainage of at point A. Now to get this length, you need to know ID and DA, right? So as you can see here, AI equals AD plus ID, and here CI equals CE plus EI. Now if you know AD and if you know DI, you can easily find the point chainage at A. Now to find chainage at A, you need to find AD and ID. Now this is explained in this slide here. Now if you look at this triangle here, ADO1, now this AD can be obtained by R1 tan theta 1 by 2. Why? These two angles here are similar angles. So therefore, this length AD can be calculated using R1 into tan theta 1 by 2, because this angle here and this angle here are similar. So this AD can be found using R1 tan theta 1 divided by 2. Similarly, DB also can be found. Why? Because DB is equal to AD according to the geometry, right? Now, then on the other triangle, you can find BE and CE as R2 by tan theta 2 by 2. Now, if you know this DE length, which is equals to DB plus BE. Now, this DE equals to DB plus BE. You can see it here. Now, if you know this DE, using sine rule, you can find this ID. So now here you can see ID is found using sine rule. If this is theta 2 and this is going to be 180 minus delta, this angle, and if you apply sine rule, you will get this ID as DE into sine theta 2 by sine delta. Now you know AD and ID. Now you can simply find this AI here. So if you found AI here, you can extend your incoming chainage to the point I and find the chainage at intersection, chainage at I. You can reduce it by IA length and you will find chainage A. Now you can find the arc lengths AB and BC and you can add it up and you will end up with chainage at point C. Now, this section I have extracted from it from your book. Now, this section is little complicated. I wonder whether I will be able to run the animation through Zoom. There is a problem of running animation through Zoom. I'll give you 1 or 2 minutes to read this out. Can you please read this thing for 1 or 2 minutes? Ali, I believe you have read it. Now, I will briefly explain what it is. Now there is a existing curve, compound curve here, and you can see there is arc section from A to B, and there is arc section from B to C. But all of a sudden, a need has come to modify this section to a new tangent. As you can see here, there is a new tangent. Now, there is an old tangent. In order to do this, they have found a method, and that method is being explained here. I will try to go to the next slide. I wonder whether the animations will run here. Now you can see for this new tangent to be connected with the compound curve to this new AB dash. This is the reduced section of AB arc length for this new compound curve. To obtain that, you need to find this new center of curvature and also the new radius. Now to do that, first you need to mark this point D here. To mark this point D, first you make a shift of magnitude P, which is equal to the magnitude of P here. This is the old tangent and this is the new tangent. Now you make a length of P and mark D here. And now you know the intersection point between these two radius which were already there, which is called O1. Then you take a radius of R2 minus R1 and you make a small arc here, taking this O1 as the center. Okay. Then after that, you can draw a perpendicular from this point D, which is already marked with a length of P, and you will end up with this new point O2. And from there, you can get this new radius, and you can take this O2 as the center for this new modified curve coming from B dash to C dash, and you can simply construct this curve. So this is the new curve, and this is the new center of curvature for this new curve segment for compound curve. Now you can find the lengths of this new curve from the theories that we have explained in the previous slide. Now we are moving into reverse curves. Here, you can see there is a directional frame from change from this direction to this direction. Now, in order to achieve this directional change, they are combining two curves. As you can see here, with two opposite circular curves. So this sort of a curve is called a reverse curve. Can you read what is there for 1 minute? I have extracted this from your course material. I think you have read it. The construction is to drop a perpendicular from A to CI and draw a parallel to CI through O1, which is the center of curvature for AB curve. And there is an intersection point called G, and drop a perpendicular from the center of curvature for DC O2 to IC and extend it up to H. Now you need to find the chainage of A here, but first you can find the chainage of I, because this is an incoming rod and you know the chainage of that. You can extend it up to the intersection point here and you can find the chainage at point I. Then after that you have to reduce this length, which is equal to T1. I equals T1 here. Now, if you reduce T1 from chainage I, you will end up with getting the chainage at point A. Now, here it has explained how you can obtain certain lengths. Now, you need to obtain this CI. C1 has been geometrically proved here. You can do it by yourself, right? Now, if you know CI, you can simply check the chainage of C, which can be obtained through this arc length adding. After finding the chainage at point A, you can add the arc length AB and arc length BC together and you can find the chain edge at point C. Now, next point is to build a reverse curve between two parallels, which is quite easy. And you can see that there is a parallel line of AD and EC. Now you want to build a reverse curve between these two lines as shown here. Now you can simplify these geometrical equations. P1 equals AF here, AF is here. AF can be found using R1 minus R cos theta. Now here this is R1, OF is R cos theta, and this entire thing is R1. So if you deduct R1 from R cos theta, you will get AF here. Now this AF is equals to P1, that is how the note has explained to you. Then P2, which is equal to CG here, can be found in similar way. So if you add the entire P1 and P2, you will get this equation. And from that you can calculate this angle theta. Also, the horizontal length between A and C can be found in similar way. If you found FB and BG here, you can add them together and you can find the horizontal distance between A and C. Now, how to find FB? FB equals to R1 sine theta. Is theta is R1. So FB here is R1 sine theta. So how to find BG? BG equals R2 sine theta. Okay. So if you add these two things together, you will find this horizontal distance between two tangent points. Now we are coming to the next section, setting out of circular curves. Now you have identified the type of curves we have to study in this lesson, and I think now it is time to learn how to do the setting out here. So basically there are three ways to set out circular curves. The first one is by chaining and offsetting. The second one is by angle and distance measurement. The third one by angle measurements only. I believe you are familiar with chain and theodolite, how it is being used to do surveying. I believe you have done surveying 1 at level 4, and in that exercise you have done your courseworks as well. Can you just look at these two figures for 1 minute? What is this all about? This is all about distance measurement. Actually, I have asked this in the exam this time, especially this section, how to set out a curve using only a chain. It is not that difficult, it is very easy. People have made a mockery out of it. Now, if you look at this figure here, which is towards your left side, here we are measuring a distance along this AI. From once you found A, we can measure distance along AI with a variable of X. So if you measure a certain distance of X, you can find a certain point. From there, if you can measure this distance perpendicular if you can measure this distance Y perpendicular to this AI at point X, you can find this point P. In similar way, you can find all the points along this curve if you can build up a relationship between this X and Y. Now, to build this relationship between X and Y, you can see a set of geometric equations are being used. Now you can see XP here equals AY here. XP here equals AY here. Now if you can find AY, you can find XP. So AY here is equals to AO. Switch off your mics, please. Somebody is disturbing. I don't know. Somebody mic is disturbing the lesson. Now, if you can find this length AY, AO is equals to R, right? Because this is the radius of this arc. Now, OY equals to R squared minus X squared and square root of that here. Why? It is the application of Pythagoras theorem, right? Now this is X, this is R, and you can find OY here. If you deduct R from this length, you can find AY. AY is equals to simple Y here. And if you apply binomial expansion here, we end up with the expansion, but x is small compared to r. Normally these curves has very large radius, and compared to the radius of this r, this x is very small. So we can only consider the first component of this expansion, and we can write this equation, and y becomes x squared over 2r. Now you can see here, in similar manner, you can establish all the points along the curve with that equation, right? Now there is another method. There is another method to establish this curve using only the chain. It is called offsets from the long chord. Now this AB straight line here is called the long chord, and if you can find the center here of this length AB, we can measure x distance from this point D towards A or B, and you can mark point X here, capital X, and from there you can draw a perpendicular line of Y to R. As you can see here. So if you can find a correlation between this X and Y, you can simply establish this curve along the transition curve. Now here you can see capital, the simple Y equals this YD equals OY minus OD, right? Now OY can be found using Pythagoras theorem, OP squared minus PY squared. Now OP is equals to R. It is the radius of the curve, and PY is equals to X. So it is square root of R squared minus X squared. And now this OD here can be found using this AOD triangle. AOD triangle. Now, if you look at this triangle, you can see AO is R, and this angle AOD equals delta divided by 2, because these two triangles are similar, right? And this is, if this is delta, this is the induced angle in the center, and half of that will be equal to AOD. Now R cos delta by 2 will give you OD, this length. So with that you can establish the equation for Y and X. Now you can mark the points as shown by this animation, and you can get the curve using chain. Now, next method is the setting out of circular curves by angle and distance measurements, right? Now, in this method, we measure angles from the tangent, and we can measure an approximate distance. This is not a perfect method of establishing curves, but it's an approximate method because here, if you can see, the arc lengths are quite similar to this chord length because the curvature is very large. Sorry, curvature is very small and the radius is very large. So as a result, you can see here the arc lengths are quite similar to chord lengths. And in all these segments, arc lengths are quite closer to chord lengths. So what we do, we measure angle from AI and and we measure this distance of this chord length along that line. Now this chord length, if you look at AP here, AP can be obtained using this equation. But actually these equations give you the arc length, but you can consider it as a chord length and you can mark it along this angle, right? But this is not a perfect method. There are better methods than this available. Now this animation will show how we do this, and you can measure an angle from the tangent which is equals to half of the induced angle. Now this is 6 alpha and this is 3 alpha. And you can measure this length now this length is equals to the length which is found from that equation. So if you know this angle, if you can mark the length along this, you can mark this point P3. Now the next method. The next method is to set up this curve using angle measurements only. Now, to do this, you need two theodolites. You will have to establish a theodolite at point A. You will also have to establish a theodolite at point B. And you will have to measure angles from both the tangents and you will have to establish this angle here. Now, I will go to the animation. I'm sorry, I had to stop and admit so many people who are coming late to this lecture. Now you can measure one angle from AI, and you can measure another angle from B, and you can establish this point P. Now the matter is that this angle that you measure from AI is equals to delta by 2 minus alpha 1. So if you measure alpha 1 from here, the angle between this P1, BI, this angle will be delta by 2 minus alpha 1. And this is how we do. And you measure alpha 1 from AI, and you measure alpha delta by 2 minus alpha 1 from IB, and you can mark this point P2. Similarly, you can mark all the points. Now, let us briefly discuss about possible problems in setting out intersection points when intersection point is inaccessible. Now, so far, in all the cases that we have discussed, the intersection point here was available. Why this intersection point is important? It is important because you want to establish point A at the beginning, and from there onwards you will have to start establishing the curve. But in case if you can't access this point I, how are you going to establish this point A? So now this example shows how we can establish this point A if you can't access this point I. Now to do that, there is a standard method. You can extend this tangent and this tangent to a certain distance where you can extend it. You can establish this point P and point Q, and you can make a line here, PQ. You can measure that length PQ, and after that, you measure the length. Then after that, you measure these two angles here, these large angles. So if you know these angles, you can calculate alpha 1 and alpha 2 here. So if you know alpha 1 and alpha 2, with sine law, you can simply calculate this IP distance using sine law, because this angle is 180 minus delta. So you can apply sine law and you can get this IP and IQ. So if you know IP, you know IAB, AP, because you have extended this line. This AP can be found. IA, of course, it is R tan delta by 2. So IA is R tan delta by 2 IA. IP is equals to PQ divided by sine alpha 2 by sine alpha 1 plus alpha 2. You can get this IP. So if you deduct AI from IP, you will get AP. So from this point P, you can establish the point A. Then the other challenge is to establish the curve when the tangent points are not intervisible. You can see from point A to point B, you can't see. So you can't measure this angle directly. Under such circumstances, there is a method to establish this. Now this angle, you can establish this curve until you can see it from point A using any other method you have exposed to so far, maybe using chain method or chain and theodolite. You can establish it up to point C. From there, it is difficult to establish it using conventional method. So to do that, you extend this line AC up to a point P, somewhere here, with a ranging pole. Then you establish the instrument here, and you can measure the same angle of alpha B here. But the theory is that alpha B equals to delta by 2. So if you measure delta by 2 here, you will able to establish point B. In this method, you can omit not intervisible object. Now this disturbs the sight distance. You can simply establish this point B. Now we want to start curve range in 2. We are going to take a small break of 20 minutes. Then after that, we will start curve range in 2. So in this lesson, we are going to mainly talk about the transitional curves with super elevation. Now, I will stop admitting any more students because I cannot keep on admitting students because it is disturbing the lesson. The requirement for super elevation. Now you have seen when you are traveling on roads, when a vehicle drives along a curve, there is a angle of road exists along the surface. Now this angle is called super elevation. This is purposefully created to make the drive smooth and comfortable for you all. And for certain vehicles, it is a must to have a super elevation in order to go through a transitional curve or a bend. Now in this diagram, you can see a vehicle is traveling on a curve, and due to centrifugal force, there is a force created which tends to move the vehicle away from the center of curvature, which is equals to WV squared over GR. We have studied these things from now this is the centrifugal force, and there is a resultant force created by centrifugal force and the weight in this direction. And if we tilt the road surface as shown in this figure with an angle of alpha, it will induce a counter force for the centrifugal force equal to W sine alpha as shown here. And this tan alpha will be equal to V squared over GR. So in order for the vehicle to travel on a path, this P cos alpha has to be equal to W sine alpha. Now this difference between two edges of the rod, the edge here and the edge on the right hand side and the edge on the left hand side, is called super elevation, and it is also known as camber, cant, or banking. Sometimes we use this word camber in engineering, in highway engineering, but the technical term is super elevation. Now for you to understand the transition of super elevation, now if you consider this as the road surface, now in the curve, the road surface has to be tilted at a certain angle. But to tilt the road to this angle, all of a sudden you cannot tilt it to an angle. So there has to be a gradual transition of this work. To do that, there is a section called transitional section on a road. Now here on this diagram, you can see there are three segments: tangent, transition curve, and circular curve. Now in this circular curve, you need to achieve this super elevation, but in this transitional curve, you need to transit. So the super elevation has to change. Now in this lesson, we are going to talk about this aspect. Now here it is clearly written the purpose of transitional curve. The first one is to achieve a gradual change of direction from the straight line where the curvature is 0 to a circular curve where the curvature is 1 upon r. I believe you know how to define curvature from your maths knowledge. It's 1 upon the radius. That is how we define curvature. Now, for a straight line, the radius is infinity, so that the curvature becomes 0. So, the second purpose of transitional curve is to permit gradual application of super elevation to counteract the effect of centrifugal force. So, they want to apply the super elevation gradually when they are taking the bend, so that the transition will be smoother. Now this is the tangent line. It's a straight line tangent to curve. And this is the transitional curve. The curvature varies from 0 to R1. And this is the full circular curve. Now this is what is happening. Now you can see here the tangent, in the tangent, the road surface is like this. And in the circular curve, the road surface has become tilted. Now, in order to achieve this transition, this transitional curve is used. I'll give half a minute to read this for you. Now, in this transitional curve, 1 upon r, which is the curvature, is proportional to length of the curve. So, O, we can write it mathematically as r into L equals a constant k. If the length of the transition is capital L and the radius of curvature of the circular curve is r, then when simple r becomes capital R, simple L will become capital L. This means now in this section here, the curvature L is 0, R is infinity. Here L is capital L, R is capital R. Now, if you take any point, it is R into L equals a constant. Now, if you apply R, capital R for simple R and capital L for simple L, capital L is the full length of the transition, capital K becomes RL. Therefore, if you substitute the K value here obtained from known values, RL will be equal to capital R into capital L, or 1 upon R, simple R equals a constant into L. Let us consider an infinitely small element dl, right? dl here, of the transition with radius and angle phi with radius r and making an angle phi with the straight if the angle subtended by this element at its center of the curvature is d phi, this is d phi, therefore dl, this is dl here, divided by d phi equals 1 upon r, which is the curvature, L divided by capital RL. And we can simplify this variable separation in this differential equation here. D phi equals 1 upon RL into simple n into DL. So by integration, you will get a relationship between this phi here, that is the angle of tangent created with the straight line with the transitional curve length L. At phi equals 0, that is here at capital T1, capital L, simple L is also become 0. So if you apply this condition here, the constant here will become 0. Therefore, the relationship between this phi and the L will be given by this equation, phi equals simple L squared by 2 capital R capital L. Now, we are going to talk about this transitional curve design. The basic requirements in this design of transition curves are, there are two basic requirements for these designs, which are listed here. The value of minimum safe radius and the length of the transition curve. The value of the minimum safe radius R is quite significant, because if the R becomes smaller, the curves become sharper. So have you traveled on hill country roads? There are very sharp bends, right? Especially in Norelia. So if you have very sharp bends, to take these bends, you need to have reduced speeds. So if you want to have a smooth transportation system, this radius has to be larger, but for a certain design speed, you need to decide what is the safest radius. Now, in order to decide what is the safest radius, a minimum safe radius has to be defined. The second option, the second design requirement is the length of the transition curve. Now here, it is been explained how to obtain the minimum safe radius. Now, there is a ratio called centrifugal ratio, and it is the ratio between the centrifugal force P, which is acting outward, to the weight of the vehicle, P over W. Now, P is the force equivalent of the centrifugal force, capital W simple V squared over GR, and the centrifugal ratio becomes V squared over GR, where simple V is in meters per second, which is the design speed of the vehicle, and G is the gravitational acceleration. R is in meters. And if V is measured in kilometers per hour, the equation has to be corrected for the dimensions, because these all parameters has to be in similar dimensions. If V is in kilometers per hour, by applying the gravitational acceleration values, they have simplified the centrifugal ratio to V squared over 127 R. Now the lesson continues. Now, if you look at the force acting on the vehicle here, there is a centrifugal force WV squared over GR. There is a fragment of that acting as P cos theta along the surface of the rod, but away from the center of the curvature. And there is W and two fragments of W or segments of W acting along the surface and perpendicular to the surface. And there is a normal reaction that is coming from the tires of the rod to the vehicle to bear the weight. So that is capital N. The lateral friction force FB between tires and road surface also exists, because otherwise this vehicle will slide down along this surface, because it's a angular surface or a tilted surface. So if we look at the force equilibrium of this vehicle, capital F equals P cos alpha minus W sine, P cos theta minus W sine alpha. If you substitute the value for P, which is capital W V squared over GR, this equation comes. Then if you think about the force equilibrium in the perpendicular direction to the surface of the rod, which is indicated here, capital N will become P sine alpha plus W cos theta. Now P sine alpha and W cos theta P sine alpha is a resultant of the centrifugal force. W cos theta is a resultant of the weight, which is W. Now again, if you substitute values for P, it will become W V squared over GR into sine theta plus W cos theta. Therefore, Fn ratio, F to N ratio here, which is the ratio between frictional force to nominal force will become this equation. So what is this Fn ratio? According to Newton's second law, this Fn ratio is the frictional coefficient mu on this surface between the surface and tires. Mu is the coefficient of sideways friction between the tires and the road surface. Now, this vehicle is traveling, but on the road surface there are two kinds of friction: sideways friction, then road friction. Here we are talking about sideways friction. Now we can simplify this equation like this shown here. Now this section explains you the curve design. Can you briefly read it for 1 minute? It is there in your book as well. Now it says certain conditions required for road design. Now for tan theta, which is the tilt of the surface, has to be in the range of 1 to 14.1 in 14.5 or 0.069. That is the maximum allowed tan theta. The centrifugal ratio, which we discussed just before, cannot exceed 0.25. As mu is also a small fraction, the last term on the right hand side is insignificant. We are talking about this term here. This is insignificant. Why? Because these figures are small figures. So if you multiply them together, mu and tan theta, they are insignificant. So therefore, this equation becomes v squared over gr equals to tan theta plus mu. If the speed given in kilometers per hour, the previous equation, which was derived for kilometers per hour, will appear and the equation will become this. This shows that the effect of centrifugal force is counteracted jointly by super elevation provided by tan theta and the sideways friction developed. So now there are two forces which will counter the centrifugal force. It is the force created by super elevation, and it is also the sideways friction. The TRLA quotes values for mu as 0.818 up to speeds of 50 kilometers and 0.15 at higher speeds. Now when we design roads, there is a particular thing called design speed. I think you have learned these things in highway engineering from Professor Veerasekara. Now, when you have high design speeds, according to that, the entire geometry of the road's design change. For example, if the design speed is 100 kilometers per hour and the super elevation is limited to 1 in 14.5, then mu is equal to 0.5. Hence, you can apply those values here in this equation: design speed, super elevation, coefficient of friction. Then you can calculate the minimum allowed radius, that is 360 meters. Now you can just apply another value here and you can calculate and see. If we applied 50, what will be the radius? The radius will be lower, right? In Sri Lanka, super elevation values varies of 0.1 are accepted. Up to 0.12 in mountainous terrains. And value of mu range from 0.2 to 0.2 at 50 kilometers to 0.16 at 80 kilometers. However, these values results in lower design standards. Now what happened is that if you apply these values, you will see the design radius, right? And it will lower the design standards. Now, the next factor that you need to consider in designing transitional curves is the length of the curve. Now, there are two methods explained in your course materials to decide the length of the transitional curve. The first one is the rate of application of super elevation. The second one is the rate of change of radial acceleration. So, as I clearly said, we need to change the super elevation to the maximum super elevation. So, you have to do it gradually. But for a unit length, at what rate you are going to change the super elevation will decide the length of the transition and also rate of change in radial acceleration. First, we'll talk about the rate of application of super elevation. Now, this is from the book. Can you read it for half a minute? Now it says about the standards established in conventional designs. A rate of 1 vertical in 200 horizontal on motorways. That means a very slow rate, very slow changing rate, right? In 1 in 100 on all purpose roads. So if you travel 100 distance, only 1 unit will change of the elevation. And 1 in 480 on railways. well, you can see railways, these rates are very high because railroads has to maintain very milder changes. Now that is why if you travel from Kandy to Colombo, the elevation rise from Ramukkana to Kadugannawa gradually. But on Kandy Road, the elevation rise from somewhere from Ganethanna to Kadugannawa within a span of 5 to 6 kilometers. But in railroad, this takes place over a distance of 20 kilometers. This is because of this rate of super elevation and rate of applications. So if the required super elevation is 0.5 meters, let's say your requirement is 0.5 meters, we need a transition curve length of 50 meter on an all-purpose road, which is 1 in 100. That means if you travel 50 meters, a 0.5 lift will take place. We need a transition curve length of 50 meter on an all-purpose road. In the case of a railway, for the same super elevation, we need a transition curve of 240 meters, right? Because for railroads, it is 1 in 480. So you need to travel a long distance to achieve the required super elevation. Can you read this for 1 minute? This is the length of transition curve continued. It explains the mathematics behind this. Here there is a derivation for an equation between V and L. Now you can see, now I will briefly explain what is rate of change of radial acceleration means. Give me 1 second to switch on my mobile camera.